Well, hey there, kiddos. We're going to continue with our discussion on quadratics. So you need your foldable out that we started in today. We're going to go to page 3, and we're going to keep talking about all the things that we were talking about today. So the first thing we're going to do is talk about how to graph a quadratic. And the way we're going to handle this is we're going to take our equation, our function that we're given, the y equals x squared minus 2x plus 1, this first one here, and we're going to type it into our calculator. And then we're going to use our calculator to fill in the table, and then we will plot those points and then answer some questions. So we're going to go to our calculator, and in y equals, we're going to type that equation. So it is x squared, and to get the squared, you push this button right here that says x squared. It'll put the little x squared up there. And then it's minus 2x plus 1. So we go minus 2x plus 1, and then to get to the table, we press second and then graph so that we can look at the table of values. And the ones that we want to look at are from -2 to +2. So on my screen here, I'm going to scoot down until I can see those numbers. There's -2, and then here's +2. So I'm going to start from here, -2 to +2, and it says 94101. So those are the numbers I'm going to list here in my table. This is 9, 4, 1, 0, and 1. So those are my numbers, and hopefully you should notice that what happens as you're going through your y values on your table is that you start to get a repeat. It went from 9, 4, 1, 0, and then back to 1. I promise you if we went to the next number, then it would repeat the 4 again. And so if you look at your table, you'll see that the next value, it repeats the 4. This is a sign of quadratics. They start to repeat like that because they make this U parabola shape. And so there's always symmetrical points. There's points on the left and then points on the right that always match up. So we're going to plot these. And so we're going to start with -2 and 9 way up here. -1 and 4, 0, 1, 1, 0, and then the next one is 2, 1. And then if we wanted to continue to be symmetrical, there would also be a point over here. We just didn't put it in our table. So now what I have is a parabola that looks like this, and I don't have the whole parabola. It stops over here, but I have enough of it that I can answer some questions. So now my vertex, it's this very bottom point right here, which happens to be at 1, 0, and you can find it in the table also because it's where the points start to repeat. So I've got a 1 and a 1 on either side of that 0, which tells me that's where the vertex is. The line of symmetry is this line that is going to cut the parabola in half. It is this line right here. We're even going to draw it in. It cuts the parabola in half right here. It always goes straight through your vertex. And so this line right here, x equals 1, it will always match the x coordinate of your vertex, becomes your line of symmetry. It's what cuts it in half. The domain for this parabola, since that's going to be all of the x values and it goes to the right and to the left forever, then the domain of this is going to be all real numbers. It's going to cover all of the values. The range goes from the vertex up to infinity because this is a concave up parabola. So it's going to start at the vertex, that y value with the vertex, which was 0, and we're going to have a square bracket there because there's actually a point there, and it's going to go all the way to positive infinity because it keeps going forever, and that's going to be the range. So let's do a second one. This time I don't have a table to fill in, but I can still do the same thing. I can go to my calculator, I can plug this in, and then I can just take those values that I see in my table and I can plot them. So we're going to type this in, the -2x squared plus 3. So we're going to go back over here to y equals, and we're going to do -2x squared plus 3. And again, we're going to go look at the table, and we're going to use the same values we used a minute ago. We're going to go from -2 to +2. And so at -2, it's at -5. I'm not sure that that's going to fit on our graph. Oh, it will. So at -2, it's down here at -5. Then at -1, it's at +1. So at -1, 1. And then at 0, it's at 3. And then at 1, it's at 1 again. And then at 2, it's back down here at -5. And so it has this symmetry going on. And so my parabola this time is concave down. It now opens down instead of opening up. My vertex is right here at 0, 3, and it's a maximum this time instead of a minimum because it's at the very top. And the line of symmetry is that line that cuts right through the vertex, and it always matches the x value of the vertex, so it's going to be at x equals 0. The domain for this is still all real numbers because it still goes to all the way to the left and all the way to the right forever because of those arrows. But now the range is going to start down here at -infinity because it opens down. And it's going to go up here to the y value of my vertex, which is +3. So when it opens up, the range ends with +infinity. When it opens down, it starts with -infinity. So that's how you deal with the range. Excuse me. So let's keep going. So now we're going to find the coordinates of the vertex using a calculator. We're just going to use our calculator to look at it and to find the vertex. And we're going to actually have it find it for us. So here's our function. We have this x minus 3, the whole thing squared, plus 2. So again, we go to our calculator. And we're going to type that in. Make sure you use the parentheses. So you have x minus 3 quantity squared. So make sure you put that whole thing in there. And then plus 2 outside of the parentheses. So that's what it should look like. And this time, instead of going to the table, we're going to graph it. We want to look at what this looks like. So here's our parabola. That's what it looks like. And we're going to have our calculator actually find the vertex. And so if you look at this parabola right here, you see that the vertex is down here at the bottom. And you could probably estimate it looks like it's at 3, 2, but we're going to have the calculator verify. This, because it's at the bottom of the parabola, is a minimum. And so we're going to have the calculator calculate a minimum. So we're going to go to second and trace. And you will see that option number 3 is minimum. So we're going to hit option 3. And now it's asking you some questions. The first thing it says down here at the bottom is left bound, which means where's the left-hand side of the vertex? Well, right now, I can't see my cursor because it's down here, it's up here at 0 and 11, so it's up here. So I'm going to have to hit my left arrow key. There it is, until it shows up. And I want to left arrow over until my little cursor is just to the left of the vertex. So about right there. And then I'm going to hit enter, and you'll see what happens. Yours won't draw this, may not draw this line. I don't know if it does or not, but it should put a little arrow right here that says, here's the left-hand side. Now it says right bound, so we have to do it again. We have to mark the right-hand side. So keep hitting your arrow, your cursor over till you get it to the right-hand side of the vertex, about right there. And then we'll hit enter again. And you see now it's marked the right-hand side. And so it's put these little arrows, these 2 little bars here, and it said, look in between here. That's where the vertex is. So now the last thing it says is to guess. So I want you to move your cursor to where you think the closest you can get to where the vertex is to make your guess, and then hit enter, and it will find it for us. And it didn't go exact. It says 2.9999. We're going to call that 3. Sometimes it's a little off. I don't know why it does this, but we're going to call that 3, 2. And so we're going to say that our vertex, first of all, we knew it was a minimum because it opened down. And it's at 3, 2. And we can verify this by going and looking at our table. If we go to second graph and we look at our table, I'm just going to start here at the 1. If you look at the 1, at 1 we're at 6, then at 2 we're at 3, then at 3 we're at 2, which is where we thought the vertex was, and then look on the other side. Now at 4 we're back where y equals 3, and so I have this symmetry, I have this repeat thing happening here. So I went 6, 3, 2, 3, and then I should have a 6 again. And so you see these numbers started to repeat. Well, this is the only one that doesn't repeat, which means that's going to be my vertex. So the table verifies it for us. That's where it is. The line of symmetry is the x value of that vertex, so it's at x equals 3. So let's list those steps again. Okay, step 1, we're going to plug the function into the calculator. So we're going to plug our equation into y equals. Step 2, we're going to graph it. So we want to see what it looks like. Step 3, we're going to go to second, trace, and then you're going to choose 3 for a minimum or choose 4 if it's a maximum. Then number 4, you're going to mark the left side. Number 5, you'll mark the right side. And number 6, you mark the vertex, and it will give you where the maximum or the minimum are. So here we go. We're going to do 2 and 3. I'm going to do number 2 with you, and then I'm going to let you try 3 and then come back and check. So we're going to do this x squared plus 6x plus 4. So again, we're going to go to y equals. We're going to type that in. We have x squared plus 6x plus 4, and then we're going to graph it. So here's what it looks like, and so you can see that the vertex is down here at the bottom of the parabola, which makes it a minimum, and we're going to find it. So we're going to go to second trace. I want a minimum, which is number 3. We're going to mark the left side, so I'm going to have to left arrow over this time because my cursor was to the right. So I'm going to bring it over here to the left side of the vertex, and I'm going to hit enter. Then to mark the right side, I'm going to arrow over so that it's on the right-hand side of the vertex, and I'm going to hit enter. Then I'm going to move it to where the vertex is. I'm going to hit enter again. And again, it did this weird thing. It says negative 2.99999. We're going to call that 3. So it should be at negative 3, negative 5. So my vertex is at negative 3, negative 5. And my line of symmetry, pardon that bell, is at x equals negative 3. And we're going to double check. We're going to go to our table, second graph. Right here, negative 3, negative 5, and you can see on either side of that negative 5, I have repeated values, and the negative 5 is the one that's not repeated, so that tells me that yes, that really is the vertex, so we're good. So I want you to pause the video for a second, grab your calculator, and I want you to try number 3. So here we are. I found my maximum, and again it did this weird thing at the bottom. We're going to call that negative 2, comma 3. And so we're going to go up here. We're going to say that this time it was a maximum because it was at the top. My vertex was at negative 2, comma 3. My line of symmetry is the x value, so it's at x equals negative 2. So there's how you find the vertex with your calculator. So now let's talk about multiple representations of a quadratic. There's multiple ways that you can see it, and you've seen some of them. We've talked about the table, and so that's the first thing we're going to do. We have our function, our equation, 2x squared plus 8x minus 3. We're going to use our calculator to type that in and go to the table. So I have 2x squared plus 8x minus 3. And we're going to fill in our table, so we go to second graph. And you can see the values that I want are negative 4 to 0, so those are the ones I'm going to type in. Negative 4 and negative 3. Negative 3 and negative 9. Negative 2 and negative 11. Negative 1 is at negative 9 and 0 is at negative 3. And so you see I have a repeating of values just like I have the whole way through, and right here is where I don't have a repeat. Negative 11 doesn't repeat, but stuff on either side of it does. This should be where my vertex is. So we're going to graph it and double check. So let's plot those points. So I have negative 4, negative 3, and then I have negative 3, negative 9, and then negative 2, negative 11, and then negative 1, negative 9, and then back here at 0, negative 3. And so here's my parabola. Move down way down here. It's concave up, it opens up, and you can see my vertex is way down here at negative 2, negative 11, just like we said. Now the next thing is this thing called a mapping. And a mapping is nothing more than a table with ovals. Okay, so we're going to have an oval over here that represents the x values or the domain. We're going to have an oval over here that represents the y values or the range. And just like when we list our domain and my range, any values that repeat, we will not write. We will only write them once. So my x values here, and I'm going to list them in order, least to greatest. I have negative 4, negative 3, negative 2, negative 1, and 0. My y values, I have, the smallest one is negative 11, then -9, and then -3. And I'm not going to write them again because -9 and -3 repeat, but I'm only going to write them once, because then what's going to happen is I'm going to create a map that shows which x values go with which y values. And I can see in my table -4 goes with -3, -3 goes with -9, -2 goes with -11, -1 goes with -9, and 0 goes with -3. So I have a map that shows which x values line up with which y values, and that's all a mapping is. You put your domain in the first oval, you put your range in the second oval, and then you just map them. Draw lines showing which ones go with which. It's like a matchy-matchy game. So the domain for this function is not just these numbers, because you can see from the graph that it goes to the left and to the right forever, so the domain has all real numbers. And the range, since it's a concave up and it has a minimum, starts down here at -11 and goes to positive infinity in the upward direction forever. So let's try another one. Now I have this. I've got y plus x squared equals -2x minus 3. Well, I can't do anything with this until this y is by itself. So the only way to do that is to subtract this x squared from both sides. So this really becomes y equals -x squared, because I subtracted it, minus 2x minus 3. So that's what I'm going to put into my y equals so I can finish this. So I'm going to go to y equals. I have -x squared minus 2x minus 3. Now I'm going to go to the table, second graph, so that I can fill in what I have, and I can see that the values are from -3 to +1. So I'm going to, -3 is at -6, -2 is at -3, -1 is at -2, 0 is at -3, and 1 is at -6. So this is at -3 and this is at -6. And again, you see I have repeating values going on here. This is the one that doesn't repeat, so my vertex should be at -1, -2. So let's go ahead and do the graph next, because I have my points and I can plot them. So I have -3, -6, then I have -2, -3, I have -1, -2, 0, -3, and then 1, -6. And so I have a parabola that's concave down, that opens in a downward direction. You can see my vertex is right here at -1, -2, right where the table said it was. So now we'll do our mapping. X's go here, Y's go here, and we list them in order least to greatest. So my X's, -3, -2, -1, 0, and 1. And then my Y values, the smallest one was -6, then -3, then -2, and then we don't repeat anything, so these don't have to get written again. And now we map. So the -3 goes with the -6, -2 goes with -3, -1 goes with -2, 0 goes with -3, and 1 goes with -6. So you have now mapped these X's go with these Y's. So when you come to class tomorrow, we will practice everything that we did today, what we did in class and what you have just done on this video. You will practice all of this quadratic stuff when you come to class. I will see you then.